3.3, number 139. We have two problems of great import for derivatives. Of which number 139 will be one of them. So 139, right? First of these two problems I want to show is finding the equation of a tangent line. To f of x at x equals a. All right, so the particular function here in 139 is what I would call a product function, because as I look at it, I see that's the most outer operation happening. 3 minus x squared. And this is happening at x equals 1. We're going to find the derivative at x equals 1, the slope of this curve at x equals 1. So to find the slope of the tangent line, slope of tangent line means find f prime at 1. Okay, so f prime, we now have rules as opposed to a definition, which will facilitate this process greatly. So f prime equals 3x minus x squared, again, times, accentuating the most outer operation there. You need to take the derivative of that product function. All right, so according to the rule, most outer operation is this, so we need to take a product rule first. We'll have the first function times the derivative of the second function plus the second function minus the derivative, sorry, I said minus, times the derivative of the first function. All right, so each of these tick marks is only applying to the second factor in these two terms. And the other factors here and here are left non-differentiated. All right, so let's see. Continuing this process, 3x minus x squared times, we will have, of course, the derivative now distributing across the difference here, because that's the most outer operation happening with this factor. Most outer operation is the differences, so therefore the derivative distributes across there using the difference rule. This x minus x squared derivative on each of them. Again, this is extremely laborious the way I'm writing this out, but it's just to explicitly show how the rules are applied. Again, you'll take some visual cues and knock these out in a much simpler fashion as you do more and more problems. The way the derivative applies to each piece will become clearer and clearer as you do more and more problems. And you will not resort to writing it out in this belabored manner. All right, so we have that, and to continue again, 3x minus x squared left alone. What happens with these derivatives here? Well, this goes to 0, this goes to 1, and this goes to 2x, of course. So we have 0 minus 1 minus 2x. Again, I would never write that 0 there, but again, just to be very explicit for the moment. Plus this factor left alone. And times what? Well, really, to belabor this again, 3 would slip outside. This constant multiple would come outside the derivative application. Look like this. I could take this one right now. I'm just going to leave it since his little partner here is not quite finished. So we'll have 3x minus x squared. The 0 does not need to be written there, of course. Negative 1 minus 2x plus 3 minus x squared. And now we finally have 3 times 1 minus 2x. So we'll have 3 times 1 is 3 minus 2x. Okay, so there's our derivatives, completely finished. This is the slope of f of x everywhere. Okay? But we should go ahead and simplify it probably before we start plugging in any values. Okay? It's always a good idea to simplify before any substitutions are made, because many times you will need to simplify for other reasons. Even though right now you could plug in the number 1 and just compute this the way it stands, a person will be better served to go ahead and simplify and get used to the simplification process, because many problems you're not plugging in a value, many problems to come, you're not plugging in a value, you're going to want to be able to manipulate this and deal with it when it's equal to something and solve for x. So we're going to go ahead and simplify this before we do anything else.